G'day, I'm Glenn Morris from the Smart Energy Lab, and look what I've got today, an AERL MPPT. Now AERL, Australian Energy Research Laboratories, founded way back in 1984. This is an Australian story. This is an Australian company, it's amazing. And this is their new 120 volt MPPT. Let's get into it. So what's special about this device? Well, a bunch of things. One standout feature is it has earth fault detection built in. Now, that would narrow you down to just a few products on the market. It's also capable of charging a 120 volt battery. That makes it pretty unique. There's not that many systems that could do both earth fault detection and charge a 120 volt battery. Of course, they come in normal, so-called normal voltage ranges, such as 48 volt. But this one is the 120. Now, here we go. Look at this. First impressions are really important. With me, it's about the packaging. It's got, I can't see any plastic. It's all cardboard. Now, hats off to whoever designed this packaging. It's engineered cardboard, see? It's a structural cardboard form and minimal. Look, there's hardly anything to get rid of. Whoa. We've got the instruction manual. I know it's nice to sort of minimize paper use completely and just use a QR code, but just a little bit of information is really handy, especially when you're out in whoop with no internet reception, which is often the case with off-grid systems using devices like this MPPT. A little bit of cardboard packaging either end, and out it comes. Now it's pretty light. There's a few more things in here. There we go. And a bit more engineered cardboard. And wow, check it out. That's a beautiful looking piece of equipment. Now, actually on the shelf behind me, if you could see it out the back there is actually one of the original AERLs, way back from the 90s. I've been using these products since 1991. And I know the company well. I know the CEO well because he's actually come here many times and we've worked on some of their designs. Just a little bit of feedback as an end user. So, what's first impressions? Very sleek design. Now, what's changed about this from the previous model is there's no screen because it's now got an app. So you can monitor this directly. So, you know, you might say, well, it was nice having a screen, but actually it's a point of failure. A screen is one of the first things that can often fail on a piece of equipment. It won't stop it working, but it's a warranty issue for the manufacturer and it's annoying for the customer. So by taking away the screen, increases reliability. I guess it reduces cost a bit, but it does have this little strip down the front here. Now, I believe that's an information strip. We'll find out in a bit, but it gives some information with just colored light on the front. The back of the unit, so we've got the potential for rear entry here. Now, that means that if we want a very clean looking installation with no cables visible, we can enter from the rear. So there's some plastic plugs here, which you can knock out. And so that's rear entry. And you can also bottom entry as well. So there we go. So we have bottom entry. You know, there's kind of like not a lot on the outside that you can talk about, really. The fact that it's got a mounting bracket. Now, if I can work it out. Yeah, there we go. There's my mounting bracket. And there's a heat sink, a beautiful black heat sink. If you can see it in the light. And this is the mounting bracket. So there's lots of options here about where this would be mounted. Lots of screw holes there. So let's get into the tech about this product. Just put it down. The product is, as I said, the 120 volt version. And so it'll charge batteries between 90 and 170 volts. So it could be used with a 120 volt flooded lead acid system, which will get you to the higher voltages, or a modern lithium battery. Now this nominal charge power is rated at 4,320 watts. But one of the really cool features, and this puts it into a very small category of MPPTs, is it can take up to 600 volt input on the DC side, on the PV side. So 600 volts. Now you're talking long strings, 7, 8, 9 panels in a string, maybe even more, depending on what the VOC of the panels are. It's got a startup voltage of 60 volts, so it starts really early in the day. So basically from 215 to 500 volts is the sweet spot in terms of the maximum power point tracking range. It's got built-in overload protection and reverse PV polarity. So if you goof it up and you put the positive and negative around the wrong way, it's got reverse polarity protection on the PV side. Don't do it on the battery side. Pay careful attention to those battery terminals. Now, I did say it had earth leakage detection. Why is that a big deal? It's actually a mandatory requirement when you've got an LV array. So when you're over 120 volts on the DC side, you need to have earth fault detection on your MPPT. And really, there are only a handful of products. I can only think of possibly 3 in Australia on the Australian market that can do this. So that's a big plus having that built in. It's got an overload capacity of 50%. That means you can actually have 50% more DC power than it can convert, as long as you don't exceed those voltage extremes. A very small self-consumption of 3.5 watts, which is just the display, and it's got communication protocols. Now, I don't know much about the communication side, but it does talk RS485, CAN bus, and USB, so that's pretty cool. And of course, it's got IEC certification. So it's got 62109 Part 1, which is for MPPT charge controllers, and therefore it would be a very suitable product in the Australian market and the New Zealand market too. Now, let's just talk about design for a moment here. Why would you use an MPPT? You've probably seen me do lots of reviews on inverters. But if you're in the off-grid world, particularly where you've got a critical application, that means you're the only source of power is the off-grid system. You don't want to find that you're in a situation where the battery system has been over-discharged, typically overnight, and shut down the main battery inverter. Now, in an AC-coupled system where all of the solar is connected to solar inverters, they only can charge that battery bank when the battery inverter is on. It's AC coupled. How does the energy get from the solar inverter to the battery inverter? It's through an AC network. And if that AC network goes down, no matter how sunny it is, you'll have no charge going into your batteries. Now, that's where MPPTs have a distinct advantage. These are DC coupled. That means solar panel, battery. That's all there is to it. The sun shines, hits the solar panel, charges the battery. It doesn't care whether the inverter's on or off. It'll look after that battery. So what's typically going to happen is if you do accidentally get into a black event, as it's called, where the inverter shuts down, as soon as the sun comes up, this MPPT will charge your batteries. The battery voltage will rise to the recovery voltage of the inverter, and the battery inverter will turn back on. So there you go. Black start protection with an MPPT. It also means you can decouple your ratios. Now, this is getting a bit more technical. In an AC coupled system, you generally have a maximum ratio of PV inverter to battery inverter. It might be 1:1. It could even be less than 1:1, sometimes as much as 2:1. But that's kind of like your limit, because how much the battery inverter can control through whether it's communication or frequency shift, that other AC coupled inverter or inverters, the solar inverters, is limited. How much it can control them, how fast it can control them. But when you've got a DC coupled system, there is no control from the battery inverter side. It's just the MPPT charging the battery. So some applications where you need a lot of energy put into the battery, but not a lot of AC power to run the loads, you're actually better off using DC coupling. That means you can size the PV array to suit the amount of kilowatt hours per day that the loads need, and you can size the battery inverter for the peak demand that the loads will demand. So it separates those two parts of the design. And you'd be surprised how often that comes into an advantage. Now, this isn't the rack-mounted model, this is a wall-mounted unit, but they make this in a rack mount. So 2 of these in a shelf will give you a lot of capacity. So you're getting 2 times basically a 4.3 kilowatt input. So that's going to be 8.6 kilowatts per shelf, 2 RU. So they'll be orientated like this in a rack-mounted system. So a 19-inch rack, 2 of these, and so you can use them in bigger applications in a data cabinet, for instance, or some form of rack mounting. Anyway, that's just a little unboxing of the AERL SRX. This is the CoolMax. I love the name, the CoolMax SRX, and you'll find more information about this product at the aerl.com.au website. I'll put a link in the description. Anyway, thanks for watching.